So solving square root equations, we need to first of all isolate the square root and then undo the square root. So here I already have the square root isolated. So I'm going to square this square root to get rid of that square root. And I'm going to end up with x plus 5 on the left-hand side. Now whatever I do to the left-hand side, that same thing must be done to the right-hand side. Now I'm not going to square like this because there's a minus there. We cannot ever square where there's minuses there. So we have to use multiplication. So I'm going to expand this out. So x minus 1 times x minus 1. So instead of using a square, I'm going to times it. So when I expand this out, I end up with x squared minus 2x plus 1. Make that equal to 0. So there's my quadratic equation. This looks like it can be factored. So I'm going to end up with two numbers that multiply to -4, add to -3 is going to be -4 plus 1. That gives me solutions for x of x equals 4, x equals -1. Now, whenever I solve a square root equation, I have to check my answer by substituting in. So I'm going to do my check. I'm going to first of all check x equals 4 by plugging it in. I'm going to end up with 4 plus 5, which is 9. That's going to be equal to 4 minus 1, which is 3. So square root of 9, I'm going to skip a step here. That's going to be 3 on this side, 3 on that side, so that's perfectly okay. So that is a valid solution. So I also need to check x equals -1. When I plug it in, -1 plus 5 is 4. -1 minus 1, minus 1. Okay, x minus 1 on that side. So I get square root 4 is equal to -2. Well, square root 4 is positive 2. So this does not equal. So this means that this is extraneous. Okay, so I've got my one solution and one extraneous solution. I can check this by graphing it. Okay, so I'm just going to graph the square root on one graph. So x plus 5, and then x minus 1 is my other graph. So square root of x plus 5 is going to look something like this. It's going to start at -5. That's my domain. And then it's going to go to the right. This equation here, x minus 1 is a linear equation that has a y-intercept at -1. And I can see that my solution of x equals 4 is showing up right there. So to show the extraneous solution, we can see that there's an extraneous solution if I draw the other half of that parabola, and there at -1, there's my extraneous solution. Okay, so the extraneous solution doesn't exist, that yellow graph doesn't exist. So extraneous solutions don't show up on graphs, but I can kind of predict where that would have been if I was allowed to have that yellow part of the graph.